This is problem 24 of chapter 20 from the textbook Stats Modeling the World. So in this situation here, let me paraphrase it. We suspect that maybe Hispanics, the proportion of Hispanics on jury trials is below what it should be, and by that we mean it should be comparable to the percent of Hispanics in the county. So there's 19% of Hispanics in the county. So we have a sample of 72 people, and only 9 of them are Hispanic. So we wonder if there's statistically significant evidence to show that that's well below 19, and so something weird is going on. Okay, so what I've done is, to just save time, I've gone ahead and written the hypotheses and checked some of the conditions. So basically, I want to prove the alternative hypotheses if I can. So that's sort of my goal. I want to make sure I have evidence to say that Hispanics are underrepresented if they are. So anyway, so I'm going to start off assuming that they're not. So the proportion of Hispanics called for jury duty is similar to the proportion of Hispanics in the county of 19%. So P, the hypothesized value, is 19. Okay? Now what I'm going to try to prove is that it's less than 19. So I write out the proportion of Hispanics on jury duty is less than the proportion of Hispanics in the county. Okay, so quickly, in this particular case, we're going to assume that the jurors were called randomly. I mean, this is basically what we're trying to prove. Okay, so this is kind of the question. So here it's more of an assumption. We're told that they're randomly selected, but let's check. Okay, then there's a 10% condition. So 72 people or less than 10% of all potential jurors in the county, so that usually that's registered voters, assuming that it's a reasonably sized county. I mean, we're not out somewhere in Montana or something, so that should be reasonable. The success-failure condition, well, here we take 72, the sample size, and multiply it by the hypothesized value. Remember, we use the hypothesized values here for our computations when we do hypotheses tests. So 72 times 0.19 is 13.68, so that's good. And 72 times 1.81, probability of failure, is 58.32. So both are, I could say up here, both are greater than or equal to 10. So the sample size is large enough to use the normal model. Okay, so we're kind of set up to just dive into the computations here. The conditions for inference are met or satisfied, so we can proceed with a normal model to perform a z-test using a mean. So the center would be the hypothesized value, 0.19. So again, we're sort of just assuming that the null hypothesis is true. So if it's true, then the center of where we would get all the p-hats, if we sampled over and over again, we would expect the p-hats to vary due to random sampling in this area. So we would compute the standard deviation of the model. So that's going to be 0.19 times 0.81 divided by n, which is what, 72? 72. Okay, and I get 0.040 0.462. So essentially like 0.5, but we're going to use some decimal places just to ensure some accuracy. Okay, so our mu is 0.19, and the standard deviation of our model is 0.0462. Alright, so let's see. Okay, now that's what we expect. Now we're going to see what really happened. So the number of successes was 9. 9 out of 72 were Hispanic. So that comes out to be approximately 0.125. By the way, it's good to use at least 3 decimal places. Okay, so where is 0.135? So here's 0.19, so it's got to be this way. Let's see, 0.19. If we take away 5, that would be here. This would be 0.14. Okay, 0.14. So we got to go a little bit further. So it's somewhere in here. I'm just going to draw a line like right about here. Okay, so this is where p hat landed, the sample proportion. So what we want to do is we want to find this area. Okay, so the corresponding z value, let's see, that would be our observed. So observed is 0.125, and we're going to subtract the mean of 0.19, and we divide by the standard deviation, so 0.0462. This is why we want to keep these a few decimal places around. So don't be too quick to round too early. Okay, so this comes out to be, when I do it, I get negative 1.41. So I might have drawn this kind of in the middle. Maybe it needs to come back this way just a little bit. But anyway, I was pretty close in my estimate. Okay, so the corresponding z value on the normal model is 1.41. So it's more than 1 standard deviation away, but it's not 2. It's about, well, it's 1.4. Okay, so the p-value, that's the probability of getting this sample. Let's see, it would be the probability of p hat less than 0.125, which corresponds to a z value of less than 1.41. So we do normal CDF, we're going to do negative infinity, right? Negative infinity, so negative 99992 from left to right, 1.41. That's going to give us the area under the curve over this domain, and that comes out to be, at least I get, a p-value of 0.0793. So double check everything that I do, because I do make mistakes. Okay, so 0.0793. Tough, because it's small, but it's not super duper small. So let's see. What are we going to do? Since the p-value, do it this way. The p-value of 0.0793 is somewhat high, at least for a p-value. We fail to reject HO. Okay? So that's kind of like the hardcore part of the decision. Now we need to add some context. So what we're going to do here is we fail to reject. So one easy way to do this is we fail to reject that, and then we just go up and rewrite our hypotheses that the proportion of Hispanics and what did we write? The proportion of Hispanics called for jury duty is similar. Called for jury duty is similar to the proportion of Hispanics in the county. Alright, so that's pretty ugly looking in. So fix that. Okay, so let's see. Well, that's just, because 7, well, almost 8%. So it could happen. It's not that rare. It's just hard to make a tough decision that has a lot of implications. Because here, if we rejected the null hypotheses, basically we're saying is that something, in my words, something sleazy is going on, and something unfair is going on, something biased and possibly even racist. So we need really hard evidence. So here we don't have it. We're close, but we don't have it. Maybe there's some other kinds of tests we could do. We could look at other proportions of other nationalities and see if it's off. Another thing, if you are worried about the test, you might want to say, well, 72 is a pretty small number, especially if it's a big county. Maybe we should use a larger n. That would tighten up this model a little bit. Maybe that would change the results. Okay, it would just cost more. That's all. Anyway, that's how you do this. That's how I did this problem. So good luck.